Hello everyone. Today we will solve Leetcode 406, which is Q reconstruction by height. See here, we have given a pair for each person. For example, if you take, let's say pair 7, comma 1. So it represents 7 is the height of that person, and 1 is the number of people who are ahead of this person in the queue, whose height are equal to or greater than 7. So it means that ahead of this, if there is how many peoples are there whose height are greater than or equal to 7? 1. So it might be possible that there is a person 7, right, whose height is equivalent to this, and let's say it is 0 or this. Okay. So first one is the height, second is the number of people whose height is greater than or equal to this person present ahead in the queue. Okay, so we have given these set of pairs, and we need to construct the queue such that it follow the particular order. So order means it will follow these numbers, right? 7 comma 1 means it will follow the height and this count order. So if you see this example, I'll explain with this example how this works. So for this example, if you look at the solution directly, which is 50703, so I'll say that why this will be the correct one, and how this is following the order which I'm explaining. So if you look at 5 comma 0, 5 is this height and 0 is saying that number of element whose height is greater than or equal to 5 will be 0. So is there any person? No. From 7 comma 0. Is there any person whose height greater than or equal to 7 ahead of it? No, it's 0. Now here, number of people whose height greater than or equal to 5 is 2. Yes, 5 and 7. So here, number of person whose height is greater than or equal to 6 has to be 1. So here only 7 comma 0 is there, which is satisfying this condition. Others are like smaller, so we don't care. Similarly here 4 comma 4, so number of persons whose height is greater than or equal to 4 has to be 4. The 6 is greater, 5 is greater, this 7 is greater, this 5 is greater, so 4. Similarly for 7 comma 1, number of people whose height are greater than or equal to 7 is only 7 comma 0, so that's why it's 1. I don't care about smaller heights. So this is for the problem statement mean. So let's think about some solution. So here, one observation if you look at, we are not making the queue in either in form of height, either in form of this count. So if you look at here, there is 5, then there is 7, then again there is drop of height, then increase of height, right? Neither is in a order of height, neither if you look at here 0, 0, 2, 1, it's increasing and decreasing, neither in this particular count value as well, right? So how you can form this? One observation here is, if you see someone's count is 0, don't you think that will be at least the first person in the queue? Means there would be multiple 0 count for the persons, but one of the 0 would be the first person in the queue. Yes, right? So I'm following that properties only. What I will do is, I will find out all the person whose count is 0, and I know that one of them will be the first person in the queue. Now you have to decide who will be the first person. Just take these two only, 5 comma 0 and 7 comma 0. Whom you think would be the first person in the queue? Just think about, can 7 comma 0 be the first element? Let's put it, if 7 comma 0 is the first element and then 5 comma 0 we are fetching, then for this person, number of people whose height is greater than or equal to 5 has to be 0. But here there is one person whose height is greater than 5, so it's wrong. So which order we need to follow? 5 comma 0, then 7 comma 0. The reason being, if there is a smaller height, we don't care. So that's why we have to put a smaller height first. Okay, so that is the first approach. So what we need to do is uh, find out all the zero heights and sort them in increasing order and pick one element from here and add into the result. And again, once you place one element, then update count of the remaining element. How we can update it? See, let's say if you place 5 comma 0 as the first element, it says that you have to update remaining element. So what are the element gets updated? All those elements whose height is smaller than or equal to 5, its count will be decremented. Right? Once anybody's count will 0, that will be a potential candidate to be the next element over here. And how we can choose them? All the element whose height is smaller. Okay. So the full approach will be, the first step is here for implementation we can use main heap. The reason being using main heap is after knowing that what are the potential candidates we have, means all those people whose count is 0, we have to choose the minimum. So that's why I'm using main heap over here. So what is the solution here? Firstly, traverse the given array and all those persons whose count is 0, add them into the heap. Okay. Next step would be remove one element from the heap. Right? Let's say you remove the element. Let's say you remove the person called P and add this P into the result. Then what you can do is remove one element from the heap and then what you need to do is update all those count of all the remaining elements, right? And once anybody's count becoming 0, then again add them into the heap. Fine. So if you think about the time and space complexity in these cases, simply let's try for time complexity. So here what we are doing is, first time you are traversing the complete array and just finding the 0 count and then adding into the heap. So traversing completely will take n time, and if let's say worst case all the elements will be added into heap, so it will take n log n. And next what we are doing is each steps we are removing one element from heap, which is, let's say I'm keep on writing as well, the first step take n log n. Then next for each element what we are doing is we are removing one element from heap, so it will take n log n only. And after removing the element, what we are doing is inside that for element which I'm removing from the heap, I'll update counts of all the remaining elements. Might be we end up updating all the elements like n minus 1 element, right? And once something is 0, that again be added into the heap. So inside that what we are doing is two things we are doing: traversing, as well as if there is 0, we are updating as well. So which will again take in log n. So if we take it, this one seems to be bigger number, so it will be O of n log n, and n is also square, n is square log square. This will be the time complexity. What will be the space complexity over here? So what we are using heap, what would be the max size? N. So O. Right. Think about some other solution. Where will be the last element be placed? If you think about the person whose height is minimum, where this element will be placed? Yeah. It will be placed at this particular index, right? Because if you consider the minimum height element, any element after it you place will have height greater than or equal to this number. So let me explain with the example only. So in this example, 4 comma 4, 4 is the minimum height. So we have to place 4 at index 4. Reason being, not index 4, index 5, because 4 element has to be greater than or equal to this. So this will placed at index 5. Reason being, as we picked this as a minimum element, so any element after it we picked up will have height greater than or equal to 4. Fine. So we can easily place this number 5. So if you place this number at index 5, let me show you the array. How it will be? Say 0, 1, 2, 3, 4 and 5. So if you place 4 comma 4 over here, then after that any element you pick, where all it will be placed? Either it will be placed here, either it will be placed here, right? So if you place over here, how this can be satisfying? Because all the remaining elements will have height either greater than or equal to 4. So any element you place here will satisfy this. Why not a 6 index or 7 index? Because if you place at 6 index, it will not satisfy, right? It has to be exactly 4 number which is greater than or equal to 4. So what about the next smaller element? We follow the same thing, right? Because once you place the element, the next element will also the same thing. Why? Let's say in this case 4 comma 4 is placed, the next smaller element has to be 5 comma 2 and 5 comma 0. Yeah, so there is 5 comma 0 and 5 comma 2. Next height would be like this. So which one we can pick up? 5 comma 0 first or 5 comma 2 first? Okay, so let's think about this. So here and how we are counting this. So over here I think we can either pick this element or this element, it doesn't matter. Reason being, if you pick 5 comma 0, it says that you have to place the element at 0 index. 5 comma 2 says that it has to place the index at 2. So it might be possible that to second index there might be some element over here, right? Then how you're computing this key? 2 element has to be ahead of this. So what you can do is traverse this array, and what is the condition? All those elements whose height is greater than or equal to current element. But if there is a vacant, where there is a space, what you consider for that? For in case of 4, why we placed over here is because there are 4 vacant space, and we consider this will be filled with the some element whose height is greater than or equal to 4, right? So the same things over here as well. So if you want to place at index 2, then how you count is go from left to right and see if there is a number whose height is greater than or equal to 5, count it. Else there is a blank space. If there is a space over this cell, that will also be considered as some element which can be greater than or equal to this particular height. So this way you can count and place the element accordingly. So in this approach, let's think about time and space complexity. So time complexity in this approach, what we are doing is, firstly we are sorting the element based on the heights. Okay, so sorting take n log n, and then after sorting, what we are doing is based on its count, we are traversing the array and finding the place and placing over there. So for one element it might be we are traversing the complete index, so it might be end up having the n squared. So total complexity over here will be O of n squared. What is the space complexity? So this array we need to return, and we are getting an array format. So no, we are not taking any extra space if you do the in-place sorting. Now let's think about some other approach. So here if you see time complexity is O of n square, right? And yeah, if you think of some other approach, so in the second approach what we are doing is we are trying with the smaller element. can't we try with the large element? Let's do that. So if we start processing the element, start processing the person whose height is highest, like from max to min, then what advantage we are getting, and what would be the algorithm? So one observation, if you see, so in this approach, if you start with the max height, what advantage we are getting? So let's say in that particular example I showed, 7 is the maximum height. So there is two persons, 7 comma 0 and 7 comma 1. These are the two persons having this max height. So if you place this max height first, then it doesn't matter if we place the smaller height at any place, right? For example, let's say 7 comma 0 is placed here and 7 comma 1 placed here. So next what will happen is, any kind of person comes, we know that those heights will be smaller than or equal to this one. So does it matter? Let's say if there is a person whose height is 5 comma 2 or something like that, so if you place over here, does it matter to it? No, because anything if you place before it only matters if its height is greater than or equal to this. Similar to here, if you want to place over here, so does it matter to this person? At all not, because any person after it anyway doesn't matter. Does it matter to it? If it is its height is smaller than this number, doesn't matter. Fine. So using this approach is beneficial because we can start with max height, and after that we can place a smaller height at any place, right? So and this you can move here and there. I mean, it's not that if you place 7 comma 0 at index 0, it will always be at 0. There might be next element comes like 5 comma 0 to be placed here. Now it becomes at 0 index and now it becomes 1 index, but it will not break the constraint. Like 7 comma 0 says that there should not be any element whose height is equal to or greater than 7 before it. It is satisfying, right? So what will be the approach here? What we can do is, firstly, sort the given array, in which we have to sort in decreasing order. Okay, so next step will be, we can take one linked list and keep on adding these elements from this particular sorted array. Here we will add, for example, let's say it's 7 comma 1, so it will be added at index, and next we just convert this linked list into the array and we need to return it. So I wanted to point it out one thing here. So while sorting based on height, if two heights are same, let's say 7 comma 0 and 7 comma 1, to which one we need to process first? It doesn't matter actually. But if you are using linked list over here, so if you try to add some particular element which index doesn't exist, right? So that there will be some problem. So to save that, what we can do is we keep on trying to add the element with the smaller count. So while sorting based on the height, if the heights are same, we need to sort this in decreasing order. Otherwise, if you firstly start with 7, let's say instead of 1, if it is 7 comma 5, and this is having the maximum height, and if you start trying with this number to add into the linked list, then there is a problem, right? Because if you wanted to add this element into at index 5, but there is no element at all in the linked, so better to sort based on this count if heights are equal. Fine. So let me quickly illustrate with the same example how this works. Okay, so this is the input for this particular example. how this algorithm work is, firstly sort it based on the height, and if heights are equal, sort it based on the count. So firstly 7 comma 0 comes, then 7 comma 1 comes, then 6 comes, 6 comma 1, then 5 comes. There is two values, the 5 comma 0 and then 5 comma 2, and then after 5 there will be 4 comma. So after sorting, this will be the array. Now next what we can do is pick the element, add into that particular index. 7 comma 0, we have to add this element at 0th index in the linked list. So at linked list the element will be like this, and next 7 comma 1 comes, then it will be added over here, and next 6 comma 1 comes, it will be added at index 1. So now what will be our linked list? It will be added over here, right? So the new linked list will be 7 comma 0, 6 comma 1 and 7 comma 1. So here, even if this element is inserted in between these two, but does it matter? No, because its height is smaller. Next, try for this 5 comma 0. It will be added at index here 0. There will be 5 comma 0. Then it will be 5 comma 2. It will be added at index. This is 0. This is 1 over here. So here it will be added. Now what is the new set of values? 5 comma 0. 7 comma 0, here it will be added, so 5 comma 2 and then 6 comma 1, then 7 comma 1. Next 4 comma 4, where it will be added? An index 4. Where is the index 4? 0 1 2 3 4. Okay, so here it will be added. So now final values will be 5 comma 0, 7 comma 0, 5 comma 2, 6 comma 1, 4 comma 4 and then 7 comma 1. If you see, it will satisfy the constraint it has. I'll pick 5 comma 2. So number of element whose height is greater than or equal to 5 has to be 2. So see there, it is right. So we can verify this, and this will be our output. Okay, let's think about time complexity here. So what we are doing is, first step is sorting, which takes n log n. Next step is adding an element into the linked list. So in linked list, we are not adding at the end or the beginning of the list. So we are adding at a particular index. So it won't be the O of 1 operation, it will be an operation. So for each element we are doing that, so it will be O n into n. So the time complexity over here, it becomes O of n square. Let's think about the space complexity. See here we are using a linked list which is of size n, so O of n will be the space complexity. Let me quickly show you my solution. So here first step is I sorted based on the constraint I told you. It's like it's need to be sorted in decreasing order based on its height, and if heights are equal, then we have to sort increasing order of its count. And after sorting, this is very simple. We have to traverse and add into the list at particular index. Index would be what? The count value of it, right? And yeah, thanks for watching. If there is any query or suggestion, please add into the comment section.